What's going on, everybody? Thanks for tuning back in. Today we're going to be taking a look at how to create a basic NodeJS Express API in TypeScript in 2024. I previously made a video on this subject a couple years back, but it's a little bit outdated, so I thought I would give everybody a refresher, and you could check out the differences in the code over the years. That being said, I'm going to list everything that we're using inside of the project below, all of the packages that you'll need, and the versions at the time of the recording. If you watch this video a year, maybe 2 years after it's actually been published, some of the packages may have changed and may not be compatible with the code anymore, so just make sure you're using the same versions. And as always, the code will be available in GitHub, and that'll be linked below, so you can follow along and do it yourself, or you can download the repository and follow the code that I provide for you. This video is going to demonstrate for you how to create from scratch, from an empty folder, a TypeScript Node.js API, and I'm going to show you how to do everything, including writing some tests for it as well. That's something I didn't do in the past, so I hope you learned something. So getting started, I've opened Visual Studio Code here, my editor of choice, to a folder that is empty that I've created inside my workspace. And I'm going to run npm init. And with the npm init command, basically you just fill out all the basic information about your project. You don't really have to change any of these except for one variable, and that's the entry point. Normally the entry point would point to something inside of your build folder, or that's generally what people like to do. But because this isn't a library, this project is going to be an API. It's going to be an actual application. I'm going to change this to my source/server.ts file. And that's because the program that I'm going to use to serve it to me while I'm editing, called NodeMon or NodeDaemon, is going to be looking at this entry point if I don't provide it a file. So I just like to change this here so I don't actually have to type it in, because as a programmer, I am the laziest. After you're done filling out your information, it's going to ask you, is all this information correct? You just type yes, and boom, you got your package.json file. So because I'm using Visual Studio Code, I'm going to be setting up my IDE with a couple special settings here so that it acts the way I want it to. I highly recommend doing this for your editor of choice. I don't know how it works in other editors, but in this case, we're going to create a .vs code folder and create a settings.json file. And inside of this settings.json file, we're going to be putting in a few things to make our lives a little bit easier. So filling out the JSON, the first variable I'm going to put is my editor.defaultFormatter. And a lot of these are going to be auto-filled for you by VS Code, which is really nice. And I'm going to select this esbnp.prettier-VS Code. This autofills for me because I have this plugin installed. So you're going to want to install this plugin if you're going to follow along the same way that I'm doing this. And if I go to the plugin section over here, you can see what the plugin actually looks like in the store. And what this is going to do for me is automatically format my code when I provide it a prettier RC file, which we're going to create in a little bit. The other settings that we're going to put in here are 3 more editor settings. So editor dot, and the first one is called bracket pair colorization dot enabled. This will make our code easier to read when we're using multiple sets of brackets and parentheses. We're going to do our format on save and our format on paste to be true as well. That means anytime we save the file or we paste something in, Prettier will automatically format our file for us. So we don't actually have to run Prettier. We can make it automatically do everything just by hitting Control S. Next, we're going to install some packages globally with npm. So we're going to run an npm install-g, TypeScript, ts-node, and NodeMon. We need TypeScript globally, obviously, so we can use it to build our project. And ts-node and NodeMon will work together to help us test our changes live. Now that we have installed these, let's go ahead and run a tsc-init. And what this is going to do is generate our tsconfig.json. This is the file that tells TypeScript how to render and build and do everything it needs to do in TypeScript with our project. Now, before we make any changes to our generated tsconfig.json file, let's create a .prettierrc file. This is what VS Code is going to use to check out the prettier settings while it formats our code. I'm just going to go ahead and paste these in here from a previous project. You can go ahead and look at the documentation for Prettier to adjust the settings the way you want it. Once I've done that, I'm going to go back to my tsconfig.json and start playing around with the settings. The first thing I'm going to do is actually use VS Code's regex search here, and I'm going to get rid of all of the comments that is generated here because it actually gives you a whole bunch of settings but comments them out in case you want to read what they do. We're not interested in that, so I'm just going to play around with the regex here to get rid of them. Basically start with a /, end with a / and get rid of everything in between. And then it's going to leave you with some spaces and just a couple of settings that are actually filled out. And once we see those settings, just go ahead and get rid of these spaces in between. And now we can change a couple things here. So the first thing I'm going to do is add something called module resolution and change it to node 16. This is autofilled for us. And I'm going to change this common.js up here to node 16 as well. This is the recommended setting, so we're just going to go with that. And we don't actually need to compile common.js because we're not making a library. Next, go ahead and add an exclude block, and inside of it, you're just going to pass in your node_modules folder. This is so we don't actually use TypeScript inside of our node modules because these are just where all our packages sit. And then we're going to include everything in our source folder. You're going to do a / with 2 stars, and then another / with a star.ts. This is just going to say that I want TypeScript to apply to all of the files in my source folder that are of TypeScript. Now that we've done this, it's time to install our packages for our actual program. Let's go ahead and run an npm install, and we're going to install 2 packages, Express and .env. Express is our API framework, and .env is going to help us load environment variables so we can change them in production builds on the fly. Now, since we are using TypeScript, we are going to have to install some types for packages that don't automatically come with them. Express is one of them. So we're going to have to actually run an npm install, and we're going to use the -- save dev to make them dev dependencies so they don't compile when we actually compile our project. And we're going to do our @types/express and our @types/node. The reason why we're adding these is so TypeScript can actually read what's going on inside of these libraries instead of just assigning the variables to any. You can use normal JavaScript in a TypeScript project if you tell your tsconfig file to do so, but we don't want that. We want all of our types tightly defined. Now you can see our project is starting to fill out with files a little bit here. So the next thing we should do is add our source folder. The first set of files we're going to create are our config files. And the first one that I like to create is our config.ts file. And inside of this is where we're going to load our environment variables, if we have any, and declare our basic configuration. So at the top, you can import .env from .env, and then you can call the .env.config as a function. And what this is going to do is automatically load any .env files you have in your root directory of your project. So let's go ahead and create one of these now and add a couple variables. We're just going to define our server's port and host name. You can pick any number that you want for the port. And for the host name, we could just say localhost because we won't actually be using this to decide what our host name is going to be. This is just more for logging purposes. Once you've defined your variables that you want to load, you can go back to your config file and create the corresponding entries here that go along with those .env variables. Now we're going to add a couple of variables here that aren't inside of that .env file that we made, but that's okay because not everything needs to be dynamic for your project. A lot of things can just stay static. So in order to create some of these variables, what we're going to do is inside of our config.ts file, we're going to define if we are in development or we are testing. These variables are both going to come from the node_m variable. So how we load that is we're going to create a variable. The first one's going to be called development, and we're going to make that equal to our process.env, which is where environment variables will sit, and node_m in capitals. And we're going to check to see if this is equal to development, making the development variable actually a bool. So if it's true, this is development. If it's false, it's production. And we're going to do the same thing by creating a test variable and checking to see if node_env is equal to test. This will be set to test automatically by the test framework when you are running tests against your code. Next, create 2 more variables, one for the host name and one for the port, and load them in a similar way that we did before. But this time for the server host name, we don't actually check to see if it's equal to something, we just check to see if it's there. And if it's not, we give it the alternative of localhost by double piping before we put the localhost definition. For the port, what we're going to do is use the ternary operator, and we're going to check to see if it exists by putting the process.env.server_port with a question mark. So if it does exist, we're going to call the number class and cast this as a number. And if it doesn't exist, we're going to use the colon and then provide it a default port. And you can put any number here that you want under 65,000, I think. Now inside my projects, there's two ways that I like to export the config. What I like to do is create a general variable that encompasses everything that's related. So I would make a server variable that holds all of my server configuration. And if you had like a MongoDB with some variables in here, you'd have them all inside of a Mongo object. And then you export everything as your config. So we can either import these by importing the names by themselves or by importing the object and getting the names from the object. You can do this either way. I'm just going to show you both examples. So here you can see I'm just exporting the const server, and I'm making this equal to my server hostname and server port. So the next step I'm going to show you is optional, and that's creating your own logger. What I do is I create a logging.ts file here inside of my config folder. And I'm going to paste this in much like I did with the prettier file. And this is just a couple of logging functions that I created where I can access logging as a global variable as long as I just import this file in my main server file. The reason that I do this is because, number one, if it's a small project, I don't really need a crazy logging library. But if you do need a logging library like Winston or something that's very complex and meets needs, like if you need to have file rotation or things like that where you print to the console and the file, then what you can do is you can actually install one of those loggers and integrate it into a file like this that you already have defined. So defining your own logger is a very good practice to help with scalability for the future of your project. Briefly looking at this file, you can see at the bottom here, I'm exporting everything. And what this does is allow me to just call logging dot in any of my other files. And I can call any of these files that I have exported inside of this logging object. Now we move on to the meat of the program, and that's the server.ts file inside of our source folder. We're going to start at the top by importing HTTP from HTTP, and we're going to import Express from Express. And we're just going to import our ./config logging file directly, and this will actually allow our global variable to be picked up and used everywhere in our application. Next, I'm going to export a const application is equal to the express as a function call. A lot of people in their projects will call this the router. You can call that the router as well if you don't want any confusion. I just like to call it application. Also, we're going to export let HTTP server and make this the type of return type. And inside of that, you're going to cast it as a type of http.createServer. I want this variable out here because I want it available to my shutdown function as well as my main function, which turns on my server. Next, I'm going to export a const main arrow function, and this is what's actually going to start up my server. And here's where I'm going to start using my logger. So if you did one like me, you could do logging.info, or if not, you could just use console.info. That's totally fine. So I'm going to actually, around everything I'm logging, I'm just going to add a couple dashes and stuff. So when it actually prints to the console, it separates everything a little bit and makes it a little bit more readable. And you'll see what that looks like when we actually turn this on. So the first section that we're going to create is called initializing the API. And all this is going to do is tell Express how to configure itself. So we're going to use the application.use, and inside of it, we're going to call express.url_encoded and set a property inside of it extended to true. And then underneath that, we're going to do an application.use express.json as a function. And what these allow us to do is give us different methods of parsing our put, patch, and post requests. You don't really need these for get and deletes. The next section is going to be our logging and configuration. So I'm just going to copy my logging from above just to make my life a little bit easier. Now here is where we're going to create our first two pieces of middleware. Middleware in Express can either do something to the actual request or it can end it depending on the conditions that are met. The first one we're going to create is our logging handler, and we're going to put this in a middleware folder called the file logginghandler.ts. And inside of it, we're going to do something to the Express request, and that's log the start and the end of it. So to create this middleware in Express, we're going to have to import three things from Express, and that's request, response, and next function from Express. These are going to be cast to our three inputs inside of our function. That way we can insert the logging handler directly into the application.use. So we're going to export the function logging handler, and then you're going to define a request, response, and next function and cast them all accordingly. Now inside the actual function, what we're going to do is we're going to do a logging.log, or if you're not using that library that we pasted in, just a console.log, and you're going to want to log a couple things. Well, you can log anything you want about the request, but I'm going to log the method, the URL, and the IP that the request is coming from. And how I get these is just access the request.method, request.url, and the request.socket.remote address. Next, I'm going to add a listener function. So we're going to type in our response.on, and we're going to select the finish method. And what this is going to say that when the response is sent out, so when it's finished, I actually want to log the same things, but I also just want to include the status, just to see what the status of the actual request was. That way, when I look at the console log from my server, I can quickly determine if the request failed or not. You can put any information you want here. You could put data, you could put whatever you want, but this is just a nice simple example. And then at the end of the handler, we're going to add this next function. And what that does is tells Express to not finish the request here, but continue on to the next piece of middleware. Back inside our server.ts file, go ahead and add the application.use, and then just put the logging handler right here. You don't have to call it as a function or anything. Everything's automatic because the application.use is already expecting the request, response, and next to be variables inside your function. So this is a neat little way to do this in JavaScript. Now we're going to copy our logging handler and create our CORS handler. And the purpose of the CORS is to determine what has access to our API and what to do with certain requests. It's basically just a little bit of configuration that you need if you want to secure your API. Now, one of the settings we're going to be putting in here actually makes it open to everybody, but that's just for learning purposes. The very first thing you're going to actually add in here once you rename the function is your res.header. And inside of this response header, you're going to say access-control-allow-origin. And this tells you what is allowed to access your API. And basically, we're just going to set it to the request.header origin, which means that whoever calls this is automatically going to be allowed. But this is where you would restrict it to certain IPs or a certain IP range or CIDR block or host name when you want to limit access to your API. We're going to add two more. One of them is called access control allow headers. And these are just the headers that are allowed to be passed to each request. And the ones that we allow are origin, x-requested-with, content type, accept, and authorization. And then finally, we're going to do an access control allow credentials true. And that's for anybody that uses username and passwords inside of the headers. You can go ahead and do it this way. So these are just some examples. Next, we can check that if our calling method, our request.method is options, this is just a way to determine what's allowed on our server. So what you can do is you can just copy this header in here and change it from allow headers to allow methods, and then return a list of methods. And those for our sake are going to be put, post, patch, get, and delete. Anything else is not going to be allowed inside of our API. Go ahead and just return this by doing a return and then do a response.status of 200, and you can just send some empty JSON. You could also do a 204, which means no content. The next function is already there because we already copied this from the logging handler. So go back to your server file and go ahead and insert this right underneath the logging handler. So the next section is actually defining our controller routing. In future videos, we're actually going to separate this into different controllers, but for the sake of being simple, we're just going to add one route here, and that's a health check, just to see if our API is actually running and return just some basic JSON. So here, instead of an application.use, you can use an application.get. You can provide a path, which in our case will be a main/health check. Don't forget the / in the front. And then call a function directly right here, passing in our request, response, and next. And this can go ahead and return a response.status of 200, and then pass in some JSON that basically just says hello world or whatever you want it to. And that's how you know your application is actually running when you call the API from a browser or from a tool like Postman. After your controllers are defined, then you're going to want to define your error routing in case the request has gone through the entire API and hasn't found a route that matches it. So what you're going to want to do is create an error route for that. Go ahead and copy one of your pieces of middleware and change the function name to root not found and name the file that as well. Inside of the actual function, we're going to get rid of everything here, and we're going to create a variable called a constant error, and that's going to be equal to a new error. And inside of it, you can just go ahead and pass in a root not found. Go ahead and log that error, and then return a response.status of 404, and return some JSON with it, and just pass in the actual error itself. Go back to your server.ts file and use the application.use and pass in the root not found handler right here. So no matter what we do with our request, it's always going to end here if it doesn't actually hit a route that we've defined. Now that we have all of our routes defined, let's actually turn on the server. So how we're going to do that is we're going to just create a new section. And here we're going to take our HTTP server variable we created at the top and make that equal to our http.createServer. And what we're going to do here is we're going to pass in our application so that the createServer function knows that this is an Express API. Then we're going to do an HTTP server.listen, and we're going to make this equal to our server from our config file .serverport, or you can import server port directly. It's totally up to you. And then create a callback with an arrow function with no props. And inside of it, go ahead and call some more logging where we can just say that the server has started. And here I'm going to add the server host name and the server port, and I'm going to call them directly. And again, that's if you want to import your variables this way. Now at the very bottom of the file, we're going to go ahead and create our shutdown function. So we're going to create an export const shutdown. And this is going to be a function that takes a callback, and this can be equal to anything. And then we're going to check to see if the HTTP server actually exists. And if it does, we're going to just use the $& and call an HTTP server.close and then pass in that callback. The reason why we have that callback is because it's defined inside of the close. Even though we don't know what that is, some things like jest can actually shut down the server with a jest callback, and we're going to pass it through that function, and you'll see what we mean later. Finally, we can call our main function directly here at the bottom of the file, and this will turn the server on for us whenever our application is loaded. Well, now it looks like we have everything defined, so let's go ahead and test the server and see what happens and see if we made any mistakes. Inside of your console, you can go ahead and just clear everything and then call nodemon. And because we have the source/server defined in our package, it should just load automatically. But if it doesn't for you, define where the file is directly. So I'll do both methods for you. So when I turn it on here, you can see that everything starts and I get some nice clean console logging. But I'm going to turn this off and actually point nodemon to the server file itself, and you'll see that I get the same result. So now I've loaded a program called Postman, and sometimes I call it Postmon, I apologize. And we use this to test all of our HTTP methods. So let's go ahead and call our localhost on port 1337 that we defined just by itself without the health check route, and make sure that it errors out because this isn't actually a predefined route. And you'll see that the error shows up, but we don't actually see what the error is down here. So it looks like we did make one little mistake. So let's go back to the program and see what happened. We can see that it logs properly, but for some reason it's not showing up inside of our response from the server that we get in Postman. So the reason that that's happening is because we actually need to pass the message. That's what we're seeing inside the console is the error.message. So if we change this to message and then use error.message, and then we try the Postman argument again, you'll see that we get the root not found error that we defined. So this is working better for us now. Let's try our main/health check. And when we hit send, we can see that it says hello world. So this is also working properly. So it errors out on routes that don't exist, and the routes that do exist work. In our case, it's just the one. Inside of the console, you can see that the server log says there's an incoming method for us, and it gives us all the information that we wanted, the method, the URL that it's calling, and the IP it's coming from. $1 just means localhost in IP6, I believe. And you can see at the bottom that it gives us a response saying that, oh, the first route didn't work. That was a 404, but the main health check gave us a status of 200. So everything's working properly. If you don't feel like doing testing, you can go ahead and stop the video right here, and I hope it was super helpful for you. But anybody that's worked on any sort of enterprise software will tell you that you absolutely need tests because they can help you find bugs you may not have found before. So let's get some testing underway. So the first thing we need to do for tests is install some more libraries, but thankfully these are all going to be saved dev because they're all going to be dev dependencies because we don't need any of our tests to actually compile for our finished project. We just need to run the tests before we build it. So the libraries that we're going to need to install as dev dependencies are TypeScript, ts-node, ts-jest, supertest, jest, the types for supertest, and the types for jest. Jest is the name of the test framework we're going to be using. You may recognize it as, I believe it comes automatically with React. I'm not sure, but I think it is the default testing framework. The next thing we need to do is go to our package.json and make sure everything is installed correctly. So you can see all of the dev dependencies here. So let's go back to our tsconfig.json and we're going to add something here. After our out directory, which should be set to build, we're going to add our types and it's going to be an array and we're going to pass in jest in here as a string. If you didn't put the out directory as a build before, I may have forgotten to mention it, so put that in here now. The reason why we're defining our types here is because we're not importing jest anywhere really, so the types won't automatically be picked up. Next, inside of our include block, we're going to add test /***.ts. And that's because I'm going to be putting all of our tests in a separate folder from the source called test. Some people like to put their tests next to their files or in folders called test inside of the folders that those files sit in. You can do it any way you like, but this is just the way I do it. Now, we have to tell TypeScript that we don't actually want to build anything inside the test folder. So we're going to create a second tsconfig file, and that's going to be called tsconfig.build.json. And when we build using TypeScript, we're going to point to this file, and it's going to make sure that it doesn't build the tests for us. All we have to do in this is add an extends variable, and that just points to our original tsconfig.json. And then a second variable called exclude, and just type in test. So it's just going to point to the test folder. You can do test / or just test. Either will work. Next, I'm just going to close all my editors because it's getting a little piled up here. And we're going to want to create a file, and that's going to be called jest.config.ts. And this is going to be the config file Jest uses to test our code. This is where we're going to define everything that we need to define to tell Jest how to test our code properly. At the type, you can import type config from Jest, and then we can create a config object called constconfig, cast that to the config type that we imported from Jest, and then add a couple variables to that. One is the preset, which is going to be ts-jest, the test environment, which is going to be node, and then the roots is going to define the actual directory that we're going to be testing, and that is the root directory inside of some chevrons /test. I'm actually going to add a couple more variables. One, I'm going to have my max workers. I'm going to set that to 1, and then detect open handle set to true. I don't think we actually need these right now, but what I'm going to do is link the documentation for the configuration below, and you can see what all these variables actually do. Next, we're going to go to our package.json file, and we're going to edit this test command because we actually have a test runner now. How this is going to work is we're going to go jest and do a --config. We're going to point to our jest.config.ts file. And then at the end, we're going to do a -- coverage. And what this is going to do is generate an HTML report for us that will show us all of the issues and code coverage inside of our tests. Whether they fail or not, you can see actually what code has and has not been tested. It's really cool. Also inside the scripts, we're going to add a build command. And the build command for TypeScript is simply tsc. And that's going to build it. But before we do that, I'm actually going to pass in an rm-rf, the build folder, because I want to delete the old build before I build the new one. I don't want any old files lingering around. So we can actually clear the console here and test this and see what happens. So running the test, you can see that there are actually no test files found. So it's going to give you an error, which is expected. So at least we know that it's picking up the configuration and everything's working. And also if I run tsc, you can see here that the build folder will pop up. So finally, it's time to start writing some tests. Go ahead and create a test folder. And then you have to decide if you're going to be writing integration tests or unit tests. Those are the two types. Unit tests basically are testing one function, one idea, while integration tests are testing an entire process. A unit test would be, for example, testing the logging.info function to make sure it called and gave you some sort of expected result. And an integration test would be starting up the server and then calling the health check route to see what it gives you. We're just going to keep it simple and we're going to write one integration test, and that's to actually test our application. So what we're going to do is create an integration folder inside the test folder, and then go ahead and create a test file. You should always name these as the same name as the file you're testing on the outside with a .test before the .ts. At the top, we're going to import request from supertest. This will help us call the functions from the test. And we're going to import the application and the shutdown from our source server file. In order to create a test, what you do first is create a describe function and pass in a string that's going to be a prefix for your actual test names. So I'm just going to say our application, or you can put the server file. And then inside of the describe call, there's going to be some more calls where we're going to fill out that sentence. So how we create single tests is create a function called it inside of the callback from our describe function. And similarly, it's going to fill out the end of the sentence. So in my case, I'm going to say our application, then it starts and has the proper test environment. So I'm going to create a test to make sure that the test environment is set properly. And inside this, we're going to have a callback as well. And I always like to make the callbacks inside of the it blocks async to make sure that if there are any awaits, they're all called properly. Next, you're going to call a jest function called expect. And this is how we're going to check to see what variables are equal to. And we're going to make sure that our process env node_env is equal to test. And we're going to check that by calling 2b on it and passing in the word test. Jest automatically sets the node environment to test. So we just want to make sure that that's actually happening. I like to check this in the main test file, which in our case is the server.test.ts file. And what we can also do is expect our application to be defined. So make sure it's not null. It actually called express properly and there were no errors. This is just an extra check you can do. You don't really need this, but there's no such thing as too many tests. And then finally, after the callback, you can actually pass in milliseconds the amount of time before this test times out. Some tests should have timeouts on them if they have calls or are waiting for things to start up. Above our it block, call a function called afterAll. And what this is going to do is do something for us after all of our tests. So the afterAll provides us with a callback with a done variable. And what we're going to do is actually call our shutdown and pass in that just callback that I talked about before. What this afterAll does is once all of the it blocks inside of this describe block complete, it will call something for us. So what I wanted to do is shut down the application, because if I try to run multiple tests at once, there might be some conflicts because they're all going to be using the same port. You can define multiple ports for your tests. There's a way to do it, but to keep this simple, I'm just going to say shut this down before using the next test. And by setting my max workers to 1 inside of my config file, I'm only going to be running one test at a time. So now if we run npm run test, let's see what happens. Now you can see at the end of the test here, we get this nice little report inside the console. Some things are in green, some things are in red, and it tells you how many test suites passed and the overall status of your tests. So this actual thing you're seeing here inside the console is like a mini coverage report. Inside your file browser here, inside the project, the coverage folder should appear for you. Go ahead and open that up and then open the subfolder called lcov report, and then go to that index file inside your Explorer and open it in the browser to see the actual HTML version of this report. And what's going to happen is you're going to see something like this, where it's going to show you all the files, and then it's going to show you the coverage inside each directory. And you can see statement coverage, branches, functions, lines. It's honestly a super detailed report for automatically coming with Jest. And what you can do is drill down into each file and see what's been covered, what's been ran, how many times that specific code block was ran. It's a really, really cool feature to show you how much of your code is actually being tested. Now let's go back and actually create a test that calls an endpoint. For simplicity, let's just call that options endpoint to see if we get the response we're expecting, where we return all of the methods. So what we can do is create a new it block and say that it returns all options allowed to be called by customers, the HTTP methods, and then create an async callback. inside the callback define a constant response and set that to await request, pass in the application, and then use the .options. And then the route is just a / because that's where the option endpoint sits. And then here we expect our response.status to be 200. So now if we go ahead and run that test again and see what happens, we can see that it passed because it returned all the options allowed, and we knew it was going to be 200 because that's generally what it's going to return. So if you want to see what a test looks like when it fails, change this to 404 because we know that's not what's going to be returned, and this should error out because it doesn't get the expected result. And that's what happens. Here inside the coverage report, inside the console, you can see what happened. You can see what the actual variable was equal to. It was equal to 200. That's what it received instead of the expected 404. And it basically gives you a breakdown of where the error happened. So this is really, really useful, especially when you're running tests against code that other developers are working on and something changes in what you expect. It's always good to have tests covering as much code as possible because it's how you're going to detect bugs before they get into production. Finally, I'm going to add one more expect block here, and that's going to be the response.headers. And then I'm going to pass in the key, access, control, allow methods, all in lowercase. And I'm going to expect that to be what I set it to inside of our CORS handler. And I'm just going to copy and paste the value of the put, post, patch, delete, and get. And then I'm going to run the test one more time, making sure that the status is expected to be 200 again, and see what happens. And you can see that everything passes again. So now that we've tested our code, let's go ahead and run a build one more time and see what happens now that we have a test folder. So you can see inside the build folder, it created a test and source folder, and we don't want that. We don't want that test folder. So we have to modify our build command inside of our package.json. Go ahead and after the TSC, add a configuration parameter called -p, and just simply type tsconfig.build.json and save that and run it again. And now you can see the build folder only contains the actual build. Lastly, if you want to see your build actually working once it's built and not being proxied by NodeMon, you can go ahead and just run node and then point right to the server.js file inside your build folder. And you're going to see that the application starts right up and it accepts a main health check route, no problem. And just like that, you've created a basic API with tests attached to it. And I can't stress enough how important those tests are and how important they're going to be to you when you're creating enterprise level software. I hope this video was educational for you. If you liked it, please give it a thumbs up, subscribe for more content, and I hope to be making more videos in the future. See you next time, guys.